So, as I mentioned before at the beginning of the meeting, today we'll talk about an integration which is very dear to us, which is the Spark integration. Because like one of the major features that we wanted to enable with the next iteration of ZenML was actually distributed programming. This is a feature which is especially dear to me because when I started working professionally in the area of ML and MLOps, one of the first things that I did was to actually dig through this area. And I remember the joy that it gave me when I first implemented something, of course, which computed something sequentially, then in a distributed manner. And seeing the difference between the two was a really exciting one. So this is an exciting integration for me personally. But I'm sure everybody who's been through the ML journey in a way where the scale is high, you can probably understand how much of a game changer this can be in terms of resources and in terms of time. And this is especially critical when it comes to processes such as pre-processing or splitting your data or any type of transformation. So this is why we also wanted to create an integration with Spark, as this is one of the most prominent tools when it comes to distributed programming. And before we dive into the actual implementation and the demo, I would like to also maybe talk about how we talked about this design. So of course, when we were thinking about this implementation, we had to answer some questions, particularly we wanted to find out how this distributed programming tool fits into the ecosystem of ZenML. And as you know, most of these tools provide a specific language and specific tool, and we wanted to create the best path for us to create an abstraction around it. And the answer to these questions actually we found in one of the concepts that we already had. Some of you might already be familiar with this concept, which is called the step operators. And what a step operator does is basically enables the execution of a single pipeline step in your ZenML pipeline in a specialized runtime environment, which is basically what we want to do with this demo. And we wanted to, that's why we decided to create a Spark step operator, which you can use to attach to any of your steps in your pipeline, and then make sure that that pipeline step runs on Spark. And for the first iteration of the implementation, we decided to do this over Kubernetes. So maybe then we can start with the demo. So let me quickly go over the pipeline and the run.py. Okay. So I hope you guys can see this. So this is the.
Paresh, can you zoom in a bit?
Yeah, sure. Let me try to do it already, but maybe let me change the window which I'm sharing with the one that I'm sharing. Give me 1 second. So I stop presenting this one. Sorry about this. So I hope this is a bit better. Cool.
Yeah.
So basically, we have a pipeline. The pipeline will have 5 steps. I try to create a story around each step of it, and I will try to explain them as much as possible. But it also takes a bit of time. That's why I would like to give it a go right now. As you can see right now here, you can see that I don't have any pods up and running. And I will tell you about the stack as well. So let me maybe quickly start the pipeline. So in order to run this pipeline, we'll be using a stack, a ZenML stack, which consists of a few components in AWS. So basically, we'll use a S3 bucket as an artifact store. We have an RDS database as a metadata store. We have a Kubernetes cluster running on EKS, and we have a container registry also on AWS on ECR. And finally, we are also using a secrets manager on AWS. I don't want to go into too many details, but for us, what's critical is the Kubernetes cluster, which is running on EKS. And what you're seeing here is all the pods which are running on that cluster. And of course, I have to update something really quickly. Unfortunately, it's gonna take me a few seconds. By the way, while I'm making the demo, feel free to jump in at any time. If you have any questions regarding Spark, regarding ZenML, would be more than happy to answer them. So that should be good to go now. Let's try this again. Cool. So what this will do now, we have a ZenML pipeline defined, the one that you can see here. And the first step along the 5 steps that we have is an importer step. I wanted to use this one because I wanted to showcase that like we made a connection with the artifact store that we have, which is on S3. And we are using a dataset actually, which is a CSV file, a dummy dataset that I've created before, which consists of 10 million rows of random data. It basically, if I recall correctly, it has 9 numerical features, 1 categorical feature, and a label, which is basically either 0 and 1. And based on this data, we'll do some steps. But the first step that we do is basically to import it. And that's what you see here. When I created this step, as you can see here, it seems like this. It basically gets a Spark session and uses the Spark session to basically read the CSV. All the other stuff that is configured will be configured within the step operator that we have here, which I'll show you in a second as well. But in order to ingest data like this with Spark, all you have to do will be something like this. And as you can see, when you do this, the step will launch a driver, which will then launch the executor pods, and will try to read this data and turn it into an artifact. I can actually show it to you on the Spark UI as well. So if I forward the, I will have to take the screen again. So this step has ended, I think. Yes, maybe I can catch that with the second step. So the first step is over, and then the second step is a split step, where we'll take this data, and then we'll try to separate these into 3 different data sets, namely the training data set, a test data set, and an evaluation data set. So the same as before, it's going to launch a driver pod, which we'll go into now. In a second. All right, that should be good to go. As you can see here, our step is now launched within Spark, which runs on Kubernetes. And you can see some of the executors, and I think the executors are getting spun up right now. So but what you can see here is the executor driver is being added. Oh, the executor is also here. Keep in mind that I wanted to also show one little detail about this. With the step operator, you also have the option to configure this as you see fit. And one of the differences that this step actually has is it features a different number of cores within the executor, which is 4. When we go back to the code, I will show you how you can also do that through ZenML and how open to configuration the ZenML step operator is at the moment. So, and you can see also the environment where the job is running right now. You can see all the active jobs, all the completed jobs, and yeah, all the things that you want to see through the lens of Spark. So now we can even maybe go back to the code, and I can show you the configuration that I wanted to show you. For that, unfortunately, I have to change the screen again. I'm sorry. So I hope you guys can see the code again. Cool. So like the importer step, the split step is actually quite straightforward as well. What we did was basically we got the data frame, which is a Spark PySpark SQL data frame, and we used the random split operation on it. And I just wanted to, let's say for this specific step, I did want to change the number of the cores and the CPUs that the Spark is running on. I set it to 4. And simply as that, I can also configure the Spark operation that I have over the code. And if you go back to the other steps, for instance, in the next step, you'll try to showcase that you can actually take these steps, like take the data frame, for instance, change it into a pandas data frame, and then save it as a pandas data frame as an output artifact as well. But as you can see, there's no like resource configuration here. That's why it's going to default to 1. I think like the 2 executor pods, which will run the Spark job, will only use 1 executor. So, I mean, this is basically how the pipeline and the steps are running. Maybe while these are running, I can also take this chance to talk about the general implementation as well. So basically, if you're familiar with the concept of step operators, you might already know this. But we have this base abstraction of step operators. And in the Spark step operator, we basically implemented an abstraction for Spark. And I think the most important things to cover here are these 3 instance parameters: master, deploy mode, and submit quarks. The master is basically the master URI of the Kubernetes cluster that you would be running. The deploy mode, you can change between cluster and client, which selects where the driver pod is running. For the sake of this demo, we are using a cluster mode. That's why the driver, you can see the driver on the Kubernetes cluster. The guys who are already familiar with Spark might already know Spark is open to a lot of different types of configuration. So it would be unnecessary to define them all by single parameters here. So that's why we wanted to enable it in a way that you can define submit quarks as a dict when you use the step operator. And you can then, these information also is used in different ways to configure your Spark job. And on top of that, when it comes to the Kubernetes step operator, you can use parameters such as the namespace and the service account that you would set up, and use it in your workflow. So while the steps are running, do any of you have any questions, maybe?
Maybe we can kick it off. Just one question. So, Harsh, in the integration of ZenML, the provisioning of the Spark cluster and the job which is running on Spark is handled all behind the scenes with ZenML. So, like, presumably, you can separate out the configuration in your step operator and then just let your data scientists write Spark code. And the value would be that ZenML would handle the spinning up and spinning down of these jobs. Did I get it right from your demo?
Yes, that's completely correct. That's a really important point. So basically, maybe if we dive into the concept a bit more. So when you create your workflows, you're basically using our Python SDK and create pipelines and steps. That's where you define the main logic. But you want to run this on Spark and you don't want to go through the configuration all the time. That's why, like with all the other components as well, that's why you use the ZenML stack. So when you want to use Spark on your workflows, what you have to do is to define the step operator once as a part of the stack. and that can be done by anyone in your team who would be responsible for setting that up, like setting the Kubernetes cluster up. But once you do that, you can write all sorts of logic which would run on that specific cluster that you define without defining anything else. Like you would only be defining the code, which you can see here. For instance, I wanted to also show this transformer step. So this is basically a set of Spark operations that I've defined, but I didn't have to go to the like the configuration level at all. That's something that I did once I set up my step operator, and that was it.
Nice. So presumably all the configuration is tracked centrally in ZenML for reproducibility. So you would always be able to see how someone ran a job and everything is tracked. Cool.
Yeah, absolutely, 100% right. So, any other question? This was one thing that I wanted to maybe showcase. Can switch back to the UI. I miss a question? The what is the Spark version which is used? Okay, it should be 3.2.1, but let me double check just in case. By the way, you can find this example also in our GitHub repository, and it's in our examples folders, and it's called Spark Distributed Programming. There you can see all the versions, all the packages, all the setup that I had to go through to get this running. And you can find all sorts of details there. Well, thank you, Hamza, once again. Any other questions regarding Spark, regarding ZenML? Okay, so I was talking, but I was muted. So maybe lastly, let me show you the UI for the trainer as well. So if we this again, let me share the right screen. So similar to the importer step that we have, this seems a bit more cooler, I guess. So this is for the trainer, where we used a random forest trainer to take the data that I mentioned to you, those 10 million rows, to train a random forest classifier. And as you can see, again, like you can see the Spark job in in all of its glory, with the executors and like the driver that we spun up. And here you can also see the classifier and like the executor here as well. So yeah. Maybe one more detail about this. For the people who are familiar with Spark, as you know, like there are different ways to launch Spark applications. And what we tried to use with this implementation was the Spark submit. Based on all the configuration and all the parameters that the step operator gets, with every step that it wants to launch on Kubernetes, it generates a Spark submit command, compiles into a entry point, which will then launch the ZenML step in the Kubernetes cluster that you have. Oh yeah. Oh, one more thing that I wanted to note with this One of the things which motivated us a lot when we wanted to implement this feature was the feedback that we got through our public roadmap. There were a lot of people voting for Spark, and that's why we also wanted to prioritize it as well. So if you have any ideas, any like features that you like to see in ZenML, feel free to join us there. Feel free to vote. Like the feedback is really important to us, and like that would be much appreciated. Hamza, if you can share the link to that as well, that would be awesome. Maybe, thank you. I was just about to do that. Cool. Are there any questions maybe?
I mean, I guess if no one's going, I can go, but maybe you can stop recording if the demo, or is there a part of the demo left?
No, I think we can stop the recording.